Dr. R. Sugurat Samuel is working as professor in physics in SRM University, Chennai. He is also training students for IIT JEE, AIEEE, and BITSAT. He has more than 16 years of academic experience both in teaching and research. He has published a book titled The Complete Handbook of Bachelor of Electronic Science Practicals. It is prescribed book in the syllabus for BSc Electronic Science by University of Madras. He has attended and presented papers in several national and international conferences and conducted many training programs and workshops. He has experience in both regular classroom teaching and also online teaching. His research areas are ultrasonics, polymers, crystal growth, and photovoltaic systems.
Welcome to UGC lecture series on Applied Sciences Electronics. We have been listening to a series of lectures on the subject Electricity and Basic Electronics for the BSc Electronic Sciences degree program. This subject is the first paper in the first semester of the degree course. This lecture is the 54th lecture in the series. In this part of the lectures, we are learning the concepts related to digital electronics, which is in the last unit of the syllabus. In the last lecture, we have learnt about the combinational logic gates, namely NOR gate and NAND gate with their truth tables. In this lecture, we are going to learn the typical circuitry part of the logic gates, how the logic gates are designed using the circuit elements like the diodes and transistors and resistors. About them we have already learnt in the previous lectures. Before we start today's lecture, let us see today's session outline. In this session, we are going to see the concepts related to the circuitry part of logic gates, the circuit design of basic logic gates we are going to learn in this lecture, what it means for DTL, diode transistor logic, the designing of OR and NOT gates, NOR and NAND gates, and also once again we are going to recapitulate the points related to the gate ICs. How the logic gates are designed using electronic components is the main topic to be covered in this lecture. What are the electronic components we are using for the designing of the basic logic gates or even the other integrated circuits that decides the way in which the technology itself is called. So, let us list out what are the names that we have for the designing of the basic electronic circuits. We are actually taking the designing of logic gates for our discussion in this lecture, but these names are common for other components or other circuit designs also. So, let us list them out. Basically, the logic gates are switching circuits. Diodes and transistors can be used as switches. Hence, the logic gate circuits will make use of diodes and transistors for their circuit design. About diodes and transistor, we have learnt elaborately in the earlier lectures by way of the study of characteristics of these two components, electronic components. Diodes and transistors are formed by the doped P and N type semiconductors fused together forming the junctions. In the case of a diode, we have one junction between the two types of materials, namely P and N type materials, and in the case of transistor, we have two junctions formed with either a P type semiconductor or an N type semiconductor sandwiched between the other two semiconductor materials, resulting in the formation of two junctions, namely the emitter base junction and collector base junction. All these we have learnt in the topics already covered. There we have learnt about the switching operation of these components. A diode could very well be used as a switch because it allows the current to flow through one direction. So, it could be used as a switch, that we learnt. The same manner, transistor mainly had two applications. One was a switch operation, the other one was the amplifying operation of a transistor. We have learnt about the operation of a transistor as a switch. In the designing of the logic gates, we will be using the transistor as a switch. That means the transistor should be made to work between the two regions, namely the cutoff region and the saturation region. In the saturation region, the transistor acts as a on mode switch, and in the cutoff region it is acting as a off mode of the switch. So, with these basic concepts we have learnt already, we are going to see how these components, namely diodes and transistors, could be used to design the logic gates. We have to keep one point in mind, that these logic gates could handle only the two states, namely the high state and the low state. When these gates are to be designed using the electronic circuits, typically the high and low mean the voltage values. It is a high state means the voltage should be high when we measure. Similarly, when we say the state is a low state, the voltage should be typically a lower value. Only the two allowed levels should be available for at the output. Then only we can have the two states of operation for these electronic circuits, which would act as gates. Let us see what are the technologies available for designing these gates. When we use the diode and transistor in the logic gate design, that is called DTL, or we call that as DTL circuits. Only the diodes and transistors would be used in the logic circuit design. Similarly, we have transistor logic called TTL. This is also one technology, because a transistor could also act as a switch. So, only the transistors would be used in that circuits. And we have resistor transistor logic, RTL, and emitter transistor logic. Again, it is a transistor related circuit design only, so it is called ETL. And integrated injection logic, IIL, MOS, metal oxide semiconductor circuits, and CMOS, complementary metal oxide semiconductor logic. The last two, MOS and CMOS logic circuit designs, would be using FET, field effect transistors. This I would like to make a mention here. It is not in our syllabus, but it is worth knowing the technologies used in designing the logic gate circuits. According to our curriculum, we will stick on to the first two technologies, namely the DTL and TTL circuit design. That means diode transistor logic circuits and transistor logic circuits. We may not be able to handle all the circuits available in designing the gates, but I would like to highlight some of the important circuits so that all the basic logic gate operations are covered in this lecture. So, let us take up for our discussion the very first gate which we learnt is an OR gate. So, let us start with the circuit design. This is the OR gate circuit design. The truth table also is also given alongside. The two inputs A and B are actually given to the two diodes and of course a resistor across which we could measure the output voltage. The basic operation of this circuit is when the A and B inputs are 0, the diodes are not forward biased. So, they will not allow current to flow through because they are not at all biased, neither forward biased nor the reverse biased state. So, the output is 0, that is the first combinational output. The second case and the third case could be discussed together. Either A or B is given a voltage, namely the positive voltage, then accordingly that particular diode would be forward biased. So, that will allow the current to flow through this load resistor and there is a voltage measured. That voltage is a high value. So, we will get the outputs and the same case exists for the two inputs as high state. So, we are using only the diodes in the forward and reverse biased conditions for designing the OR gate. The concept that we have to keep in mind here is the forward and reverse bias conditions of the diode, the two diodes used here, make them work as a OR gate. And what is the voltage we need to give? We need to give a voltage of 5 volt as the input for this typically shown circuit and the output would also be a 5 volt. So, the 5 volt represents high state and 0 volt represents the low state as far as this typical circuit design is concerned. And for the designing of the AND gate, what are the components to be used? So, let us quickly have a look at the designing of AND gate. For AND gate circuit, again the two diodes are used, but the way in which they are connected is in the reverse biased condition. The terminals are reversed and again these two diodes could either be forward biased or reverse biased based on the input that we give. Already the two diodes are in the forward biased condition. See here, to the P regions already a 5 volt is connected, source is connected as VCC. So, they are connected in the forward biased mode already, but the way in which we measure the voltage is slightly different here. We do not have a RL at all, we measure it across the output point and the ground. That ground is common for all the inputs, the two inputs AB and also the VCC. So, when we measure the voltages, we will be able to get the outputs accordingly. I will explain the output for each combinational input with the diagram which I have shown after a short break. Welcome back. We are discussing about the AND gate and its operation for different input conditions. So, let us have a look at the diagram and see how the circuit design would act as a AND gate. As I already told, the two diodes are already in the forward biased condition, but that is to be decided based on the inputs that we give here at the point A and B. For the first combinational input, both A and B at lower potential, the current flows in the circuit because it is in the perfect forward biased condition. The diode D1 and the diode D2 will conduct current from this point to the inputs because they are at a lower potential. So, the output will not be there, it is at a lower potential value. And the same thing exists for the other two combinations, either A or B as 0 here, because any one of the diodes will be forward biased. So, they will conduct. So, again the output is 0. Only for the two inputs as high value 1 and 1, the diodes cannot allow the currents to flow through them, that will appear across the output terminals, the two terminals. So, only for that last combination, either both A and B as high value, the output is measured as a high value in the circuit. So, again for the designing of AND gate, we are using the two diodes as the circuit components. Now, it is time for us to look at the components used for the designing of a NOT gate. How a NOT gate is designed? Let us have a look at the diagram. For a NOT gate circuit, we are using a transistor. We can also use some of the diodes, but at this point the connections would be little cumbersome when we use diodes, but a simple circuit in which one single transistor used as a NOT gate is taken up for discussion here. So, it is a NPN transistor because the arrow mark is shown outwards at the emitter. So, it is a NPN transistor. We have the base resistor and also the collector resistor connected. So, it is connected to the VCC, which gives the proper biasing condition for this transistor. Now, whether the junctions are forward or reverse biased is going to be decided by the input voltage that we give here at point A. Let us take the first input, which is 0 here. So, when we give 0, the circuit here, this junction, the base collector junction is in the, because this collector here is a N type material and the base here is a P type material. So, this junction is reverse biased. So, it will not conduct. So, the entire potential is dropped across this itself. So, when we measure the voltage across this point which is marked here and the ground, it will be a high value. So, it shows the value 1. And in the same manner, when we give the input as 1, which is a high value, this part is forward bias, the current flows. So, across the points that we have decided here, the output points, we have a 0 as the output voltage. So, the complementary values are obtained as the output for the given inputs. So, the transistor is used in the saturation and cutoff region for acting as a switch. So, for a NOT gate, the preferred electronic component is a transistor. We have seen the circuit design for the three basic gates, namely OR gate, AND gate and NOT gate with the DTL logic, diodes and transistor logic. Now, the combinational gates also could be taken. How do we design the NOR NAND gates using the transistors? Also, we can use only the transistors for the designing of OR gate and AND gate. We need not even use the diodes. Even transistors could be used as the switches in the case of OR and AND gates. So, let us see the circuits quickly one by one. What are the components used for the designing of each circuit. This is a circuit showing the OR gate with the help of only the transistors. These two transistors are acting as the diodes which we used in the case of OR gate design with diodes. Again, there is a VCC required for them, but the operations are similar, and here the point to be noted is the output is measured not across the collector and the ground, but it is measured here across the emitter and the ground. The two emitters are connected together here. So, these two transistors actually act as the diodes which we used in the earlier circuit which we have seen. The same manner AND gate with the transistors. This is how we have to use the circuits. I am not going to discuss component by component for the operations because it is very well mentioned. The transistors could act as switches. So, that concept itself is enough. With that knowledge, we can have a look at the circuits, and the operations are very simple because we have learnt already how transistors are used as switches. Now, the AND gate is designed using only transistors in this manner. Now, we will take up for our discussion the combinational gates like NOR and NAND gate. For a NOR gate, we have these diodes which was already discussed, and along with that one transistor is used for the NOT operation. The NOR operation is a OR operation followed by the NOT operation. So, here the same manner we have taken two diodes. This part is the OR gate part and this is a NOT gate part. So, here I think we get the typical meaning for the DTL, diode and transistor logic. Basically, we will be using NOR and NAND gates for implementing the logic operations. That is why in the NOR and NAND gate circuit designs, it is inevitable to use both the diode and transistor. So, I call these logic circuit designs as DTL logics, and also the diodes could be replaced by transistors. So, in that case these circuits would come under the category called TTL, transistor logic. So, let us have a look at the NAND gate design using these components. In the case of NAND gate, again we are using the two diodes and a transistor. These are just typical circuits. So, without much explanation, the regions only I would like to mention. This is the AND part and this is the NOT part. The AND followed by NOT is only called the NAND gate. So, again this comes under the category of DTL, diode transistor logic. So, like this we can also take the pure transistors for designing the NAND gate. I would like to leave all those for our discussion. I am not going to include them for this discussion. They all could be easily gathered from outside, and these are some of the basic logic gate circuits I wanted to emphasize. Now, it is time for us to learn about the integrated circuits which are incorporating these electronic components in them. In the last lecture itself, I have briefed about the designing of logic gates in the form of integrated circuits. Now, once again I would like to mention here because it will enhance our understanding and also wonder about how these circuits are all designed in the integrated circuits. So, let us have a look at the gate ICs and know how these circuits are incorporated in small chips. Integrated circuits. An integrated circuit referred to as an IC, a chip or a microchip is a set of electronic circuits on one small plate called chip of semiconductor material, normally silicon. This definition we have seen already, and I would like to show some of the typical ICs, how they would look like, the integrated circuits. I would like to recall to our mind the logic gate ICs are having 14 pins, 7 on one side and the other 7 on the other side. The power is given to these ICs to make them work is given to the pin 14, and the 7th pin is always considered as the ground. So, these two pins or the output terminals are meant for giving the necessary VCC for the gate ICs, and the remaining terminals are typically the gate terminals. I have shown a typical gate IC layout in the last lecture. Once again I am going to show and I am going to explain how these circuits are designed in the gates. So, let us have a look at the typical picture of a IC. The ICs, commercial ICs, they look like this. This is a 7400 series. So, it is typically a gate IC. It has 7 legs. When we count, it has 7 legs on this side, on the other side the remaining 7. So, these are some of the ICs which are commercially available. How the gate circuits are incorporated in them. So, once again we have to look at the layout of the gates in the respective ICs. I would like to show the 7400 series for the discussion. This diagram is a very familiar diagram right now for us. It is a 7400 series. If suppose this NOT gate is to be designed in this IC, each NOT gate has a transistor in that. So, it gives us an idea how the electronic circuits are incorporated in the ICs. The IC design itself is a very big technology. It is beyond the curriculum for us to learn about all that, but it gives us this in this lecture, these points we discussed give us some idea about the designing of logic gates. Now, it is time for us to look at the summary of today's lecture. In this session, we have seen circuit design of basic logic gates, the diode transistor logic, the designing of OR and NOT, NOR and NAND gates we have seen in this lecture. Let us test our understanding by answering these questions. What is DTL? Design OR AND gates with diodes. Give the circuit of NOT gate using transistor. What are integrated circuits? Give an account of gate ICs. So, with this I would like to wind up this lecture. We shall see the other concepts related to Boolean algebra in the forthcoming lecture. Thank you.